We're going to continue a new way of looking at something that we learned before called a quadratic equation or a quadratic function. It's basically in the form of ax squared plus bx plus c equals 0. And I'm most able to identify this as a quadratic when there's a x squared term. It's a polynomial of degree 2, and that defines it as a quadratic equation. Well, before we were able to solve these quadratics through our factoring strategies. But what if it doesn't factor nicely or cleanly or into integers that we're aware of? Can we still do it? And what we want to explore here over the next few sessions is that I think we can. And so let's develop some tools, build on some existing tools that we have in order to solve something like this that doesn't factor. So let's take, for example, and we're just going to build slowly to that. So just work with me. Let's say that I have something that looks like that. Well, what are its solutions of x? Well, this particular one, we can look at how we've done it in the past. I can subtract 9 from both sides. And now it looks like something that I can factor. But I wanted to use this as an illustration to show us something else. One other tool that we can do is we're basically asking what times itself makes a 9. And I think we can kind of look in the recesses of our mind there and realize, well, that 3 squared equals a 9. So one of my solutions must be a 3. Well, likewise, if we're familiar with how negative numbers multiply, we can also imagine that, you know what, I bet you a negative 3 would also have to be a solution because negative 3 equals a 9. And notice how I wrote that. I wrote the negative 3 all in the parentheses. I did not write that because that is not a true statement. Negative 3 squared equals a 9. That's not true. That equals negative 3 to the square equals a negative 9. So understand the power of the parentheses. Anyway, side note. So what I want to introduce you to as we begin this chapter is this idea about a square root property. And what that means is that if I have some equation, some function that I can identify as something squared equals some number or some other unit, some other term, whatever it might be, is I can take the square root of both sides. And that produces a u, in this case, equals the square root of d, and the negative of that square root of d. And sometimes we write it as plus or minus square root of d. So can you see that happening here on this x squared plus 9? I took the square root of both sides. I'm left with an x, and that equals a plus or minus square root of 9. That's a 3. So this idea of the square root property, we're going to unpack a little bit to show you the power of it. You may not be convinced right here on this example that we can work lots of different ways, but trust me, we're going to find its power here soon.